Okay, hello class. We're going to look at some more transformations now. So we're continuing to remember to think about the theme at the top of your sheet in addition to using the various advice on transformations throughout. So remember, the theme is inside is horizontal, and the basic operation is going to be the opposite of what you expect it to be most likely until you get used to it. And outside is going to be vertical, and it's going to do basically exactly what you expect if you have some decent number sense. So let's look at transforming this function, f of x equals -4 plus this absolute value. So this time our parent function is something that's not just the basic v shape. So we're already starting with a function which has some transformations in it. And I also want to show some calculator in this. So we'll be checking our answers with our calculator as we go. So let's talk about what we have transformationally in this problem. So far the parent function, before we even do any reflection, is already has a -4 out here. It's out here. It's outside of the absolute value bars. That means it's going to be a vertical kind of shift, and since it's just -4 added on to, that's really just the same thing as if it was -4 over here. So the fact that it's in front has no difference. It's being added on to -4. So that's the same thing as taking the absolute value and subtracting 4 from it on this side. So that's going to be down 4. Excuse me. Inside the absolute value, we have a +2. So inside, the rule of thumb is to think horizontally or sideways. And what way is plus? Well, you want to probably think that plus horizontally is this way, but remember, horizontal, we got to think the opposite. So it's actually to the left. So we've also got a left transformation, or slide translation, they call it sometimes, by 4. Another way to think about that, just going back to something we did in the previous lesson, is remember you could rewrite this part right here as x minus a -4. And how do you read that? You read that as the distance between what you want, x, and -4. And -4, as we all know, in x land lives to the left. So let's go ahead and graph that guy, and we will check it in our calculator in a second. So let's see, we're going to take the absolute value v shape and go left by 2. Slope 1/1, so it should hit 2 on this axis as well. That should give me about the right 45-degree slope 1/1 angle on my absolute value. So I only went left. Oh, excuse me, I should have gone. This is supposed to be a 2. Sorry about that. It's not the same otherwise. So left by 2, and I didn't go down 4. You know, I'm just going to go ahead and erase this guy and go down at the same time. So we'll go down 4 as well. 1, 2, 3, 4. So left 2, down 4, up 1/1, up 1/1. It's going to cross right there. I have a nice point for scale. So there is f of x. So our first task on this problem is to create a function that reflects it over the y-axis. So as soon as you see this word reflect over the y-axis, my suggestion is to try to make it a little simpler. First of all, which one of these axes is x and y? This is going to be the y-axis. So we need to take this shape and flip it that way. I guess this vertex is going to go on this side now. So how do you do that? Well, first of all, I'd be thinking, am I flipping it sideways or am I flipping it up and down? It's clearly a sideways one here. So personally, I would always write a keyword, a little hint to myself that says flip it to the right or sideways or something like that. So I'm going to say sideways on this one. And now you can either follow your sheet, but you want to wean yourself off of that, remember. So sideways is a horizontal thing. So the negative that's going to reflect us, if it's a horizontal thing, think, should it be inside or should it be outside? Since it's horizontal, the rule of thumb is inside. So we're going to see our new function. I'm going to call this one g. That's the most common name for a new function that's been transformed from a parent. I'm going to put my negative inside of the old function. All right, and then the function notation tells me exactly what to do. Grab that and stick it in for any x's in the function. So we're going to say, let me scoot this over a little bit. We're going to say g of x is f of -x. So I'm going to take -x and stick it in. So I get -4 plus -x plus 2. There we go. Let's see if that actually does this kind of sideways reflection that it's supposed to using our calculator. So I'm going to go to my calculator here. And we all know that functions get entered. I'm going to clear out what I have. Functions get entered by pressing y equals in the upper left. You can see that I already have some functions in here from another class. I'm going to clear them. Make sure plots are not on. If it's on, it's going to be bold. So if it's bold, turn it off. Just go up there and click enter. I'm going to put my original function in, f of x. So absolute value is math. Look around for it. I don't see it. There it is. Absolute value of x plus 2, and we had a minus 4 outside, didn't we? See, I just wrote it like that. This time it's the same thing. So let's hit zoom standard, and that should give us our absolute value shape that we see on the board. Looks good, I think. There we go. So now let's put in g of x in a second function. So back to y equals, get my absolute value, math, absolute value, x. Oh, it was not x, right? It was, let's put it in just like on the board. Negative 4 plus. Notice I used the small negative here at the beginning. The big negative goes in between things. At the beginning of expressions, you need to put the small negative. That's just a quirk, kind of an annoying one, but you'll get used to it with these calculators. Go grab my absolute value again, put in negative. See, it's the small one for the beginning, plus 2. Let's see, there we go. Let's see if this looks right. Did it actually reflect it? So think about the non-bold shape and think about if I flip it this way, is that what it's going to look like? I think the answer is yes. So we're good to go on that one. The second question on this problem asked us to reflect the same function, this blue one. Let me get my green reflected one over there. I'll label it g of x. It said take the blue original function and now flip it over the x-axis. Well, this is of course the x-axis. So do we want to flip this sideways or do we want to flip it up and down? I think it's clear that it's going to be up and down. So I'm just going to write that to remind myself. I want to flip this down, up, you can say vertically, anything like that. Because basically the thing you're trying to get in your head is going back to the rule of thumb. Is this horizontal or vertical in terms of the transformation? It's clearly vertical, that's up and down. So the negative for the transformation is going to be inside or outside. Since it's vertical, vertical stuff happens outside. So I'm going to give my function a new name. H will be my transformed gun this time. And negative has to be outside the old function. So now I'm just going to do that and say negative and take my old function up there and write it down. Negative times negative is positive. And let's see if we got this one right. So I'm going to go ahead and go to my graph and type it in. So you could put all three of them in there. I'm just going to delete our horizontal transformation first and type in what we've got here. There's our f. And that is supposed to be our h of x, our new function. So ask yourself, did that take this picture and flip it over? Well, clearly not. So where did we make a mistake? We'll go back to what we were supposed to do here with the algebra and the function notation. This says the new function is negative the old function. And it doesn't say negative part of the old function, does it? It says negative all of the old function. So now look what I did here. I did negative the first piece, and then I totally ignored that second piece. Really, I should have parentheses there. And if you look at the hint on your transformation sheet, it's going to say, remember, on things like this, make sure you multiply any number throughout. But just use common sense, and you should realize this negative needs to be distributed to both terms. The mistake was right here. Let's see if that fixes it. There we go. Now we've got a vertical reflection. You can see that definitely fixed it. So while you're doing this, make sure you check with your calculator as you go. Let's look at a couple other more exotic transformations. Let's do a vertical stretcher compression and let's do a horizontal stretcher compression. So let's get these guys out of the way and look at a new function. So first, let's take the function f of x, I don't know, let's do a simpler absolute value. Let's just say it's shifted down by 3. And let's take that and stretch it vertically. So let's say f of x is stretched vertically, again the key word here. Now let's say we stretch it vertically by factor 4. Let's see what happens to this function. Alright, so first I'm going to draw my original function. So that's just outside, minus 3 is going to be what you expect, down 3. V shape, so it should be up 1 over 1, which means you should hit 3 over on the x-axis. So there is f of x. We wanted to create a new function that stretches that by a factor of 4 vertically. So first, the key with these is to picture it. Use your hands, or at least think about it in your head pictorially. So think about this function and grabbing onto the blue parts all at once, if you will. And think about vertically stretching it. When you do a compression, you should be thinking about taking this V shape and smashing it down like a sandwich and thinking about what happens. So vertically, I'm going to be grabbing onto all the points and stretching it up. So it's going to get steeper, obviously, on this one. So let's see what that looks like in notation. So g of x, this is a vertical thing, so the thing that we're doing, the transformation, should be outside. So that 4 should be outside of the original function. And if you're stretching, it should be pretty natural to you that that's multiplication. Compression is going to be division. Outside is what you expect. So there's no opposite phenomena in this problem. So I'm just going to follow my notation. It says take 4 times all of f of x. I'll put f of x right here and go like that. So many of you watching the video should be screaming at me right now because the simplification of this is not just 4 absolute value of x minus 3. That says 4 all of f of x, so you really need some parentheses here to distribute that 4 and its effect. So really, I'm going to be going down 12 now on my new function. So it should be way down here, down at 12. And the slope on it, instead of 1 over 1, is now 4 over 1. So we're going up 4 over 1, up 4 over 1. I think if you do that, you're going to actually get it to go right through this same spot. We'll check it on our calculator and see if I'm right. So there you go. Another thing to notice before we check this on our calculator is look at it. Besides actually getting steeper, something else happened. What else happened? Think about it for a second. What else happened was the vertex of the absolute value moved. It actually got moved too, but that should make sense. If you think about grabbing onto the blue guy and stretching it out, when you do that stretching, is my bottom finger going to stay stationary while my top one stretches up? No. If you stretch it and stretch it vertically in both directions, that bottom part is going to slide down further. So that should really make common sense, I think. Let's double check in our calculator and see if we've got it. So I'm going to go original function, and 4 times it. If you want to really be crazy here, you can actually check yourself. So I could type that right in and we get the picture we will on the board. Here's a way to see if we actually did the distributing part right. You could just say 4 times f of x here. What did we call f of x? We called f of x y1. So if you know where y1 is on here, you can just press that. So if you go variables or vars, and then you go over to y vars, and we're working with functions, you can see that's one way to get y1. So that's a fancy thing, you definitely don't have to use it, but something we use in higher level classes a lot. So let's see if it looks like that. There you go, you can see it's off the screen down below 10 here. Let's look at one more problem before we leave off of this lesson. So let's think about the toughest kind of transformation, I think, which is a horizontal stretch or compression. So let's take a function like, I don't know, try to keep it pretty simple still. Let's take a function like x minus 2 plus 1. Now let's take that function and transform it. Let's say let's compress it horizontally by a factor of 1/2. So first we're going to draw it again. Let me get this one off here. So let's see, we're going to draw the original function. So outside we have plus 1, that's vertical, that means up 1. So up 1. Inside we have minus 2, or the distance between x and 2, not negative 2. So that's right by 2. So there's the new vertex. There was no stretch or anything, so it should be up 1 over 1 for the slopes on those v lines. So now I want to take that and compress it horizontally by a half. So just think about this first. Take that V shape and imagine grabbing it at all points if you can and smashing it horizontally. This is a horizontal smash, right? This is a vertical smash. Think about grabbing that V shape and smashing it horizontally and what would happen to it. So really, if we smash it horizontally, it's going to be the same thing, I think, pretty much. Not exactly, but mostly as stretching it vertically. Let's do the algebra. So I'll do this one in green. So we'll say our new function, g of x, is going to be the old function. Horizontal stuff happens inside, and it's the opposite of what you expect. So compress, stretch, that's like multiply or divide. Compress, you should expect a division. I think it's actually going to be the opposite. On your sheet, there's a nice rule of thumb, though. It says take f of x and take that x and just put the factor right underneath it. So there's the cheat. You're going to see the opposite part in a second here, because if you divide by a fraction in algebra or mathematics or any class, you should remember from middle school or wherever, that means copy dot flip. It's multiply by the reciprocal. So copy dot flip. Simplify, and you get this. This says take 2x and put it in any slots in the function, so I'm going to. And there's what I get for this horizontal compression. Let's see if it actually did this kind of thing with our calculator. So I'm going to put my original function for comparison. Don't skip out on that. That's always important. You want to be able to compare. Oh, I'll put it right here. And our transform function I'll make bold, just like the other times. So there's the first function in blue. And it does look like it has been compressed horizontally. If you look carefully here, though, it looks like something else kind of sneaky has happened. Even though this is very much like a vertical stretch, if you grabbed this and vertically stretched it, this vertex would move down. But if you take this and horizontally smash it, this vertex this time moved to the left. But look at your algebraic function. You can see if you read this, that says up 1. This is like some kind of stretch or compression. And this should tell you, if you've been paying attention, right by 2. Is it right by 2? Let's zoom in. So I went ahead and zoomed in, and this one's right by 2, the original, and this says it should be right by 2, or does it? Because it's not. The calculator says that's right by 1. This is one of our first encounters this year, not the last, definitely, with what I like to call a sneaky transformation. Even though that should say right by 2, and if you were thinking right by 2, you're doing really good right now. As we begin transformations, this complicates things. Really, you have to factor this out inside to see the true transformation. So those share a 2, so I'm going to pull it out inside and say what's left is x minus 1. That's how you see true transformation. So if you ever run into a situation this year or in the future with transforming any function, not just absolute value, and there's more than one thing inside, you have to make sure the inside is factored or you won't see the real transformations and it won't be what you expect, like on this problem. So that's something a little bit sneaky. We'll keep working with it as we go through our library throughout the year. I'll see you next time.